So connective tissues are generally less effective at contraction. And what that means is that if I take my arm here and I want to go into flexion, the connective tissues itself aren't making that happen. It's mostly the muscle in your flexors, your biceps here, or your brachioradialis, that is allowing you to flex the arm and not the actual connective tissue, the fascia. But the fascia plays a crucial role in being able to do this, because if you have tight fascia all throughout here, your arm, your bicep is going to have to work a lot harder, maybe having an overuse injury or something along those lines, in order for us to bend our elbow. So all of this could be tight, because we know that the connective tissues itself, the fascia, secretes collagen and elastin, or the collagen is allowing us to be flexible enough to do this, along with the elastin, because of how those fibers are made. In areas where myofibroblasts are present within the fascia, because of the myofibroblasts, it says that it should be able to contract. However, it's not attached to a neural synapse, so that means that we have no control over the ability for it to contract. It would subsequently just contract when your muscle is contracting. The research still needs to be a little bit more on this, as it is fairly new. What we also know about myofibroblasts is that it's going to help in wound healing. So when we damage that fascia, you're going to have some more systems to help repair it, which that fact is important for us to know when we have fascial tissue injuries. Where you can find these specific myofibroblasts is in the lumbar fascia, the fascia lata, the crural fascia, the plantar fascia. Basically, where you see like a large sheet of fascia is where we generally find those myofibroblasts, so where we can repair them. Understanding the diverse function of fascia tissue, where there could be the potential for contractile tissues, whether or not we can neurally make them contract or they contract on their own. We now know that we can manipulate the fascia because it secretes collagen and elastin, and it has the myofibroblasts, so they can repair the function of the tissue. Those are definitely important things that we need to know while manipulating the structure. It's not just for stability, although that is their main purpose. Another key function of the fascia is that it's going to assist in the gliding and the fluid movement. It's going to reduce the friction between the muscles and the fascia. So when we talk about moving our arm, my fascia and my muscles have to glide and move in order for me to effectively do that movement. Fascia's main role is structure and stability, but it not only does that, we also see the myofibroblasts present, so it has repairability and contractile ability, whether or not that is through the neural, it's not through the neural synapse, so we can't control it. However, another part to the fascia is that it's a highly innervated tissue, so that means that there is nerve endings in the fascia, which is why we feel the pain, because there's nociceptors there. It makes it sensitive to touch, to pressure, and to pain. The nociceptors play a crucial role because it's going to signal to the brain that there is pain and that there is damage in the tissue, so that you know about the pain and the damage, so that you don't do it further or you stop your activity to protect itself. It doesn't matter if it's due to overloading or if it's due to a sudden trauma. It doesn't necessarily matter how that pain happened. So now we've learned that they are structure, support. We've learned that there's pain, nociceptors. We've learned that there's myofibroblasts. And now we also need to understand that it changes consistency under stress. So that means that the fascia is going to change when we do a movement. So in the back here, when we move this, all of these fascial stretches are now going to change in order for me to do that. We can help regain the elasticity because we have learned that it secretes the collagen and the elastin and the fibroblasts for the reparative function of the fascia system. Okay, brief overview of what we just learned, because this is pretty imperative in the understanding of the importance of fascia. So we know fascia is a main structural stability tissue. It also can contract, but it's not through the neural synapse, so we can't make it contract. However, we know that these muscles can contract, most likely because we know that it can change consistency under stress. We have myofibroblasts, and those are going to be mainly for the reparative function and a little bit of that contractibility. And then we also know now that nociceptors and nerve endings are in fascia, so we can feel pain through fascia. Fascia can cause pain in the system, which is why we need to manipulate it and regain its elasticity, because we know that it secretes collagen and elastin.